been done. So let us come to a beautiful application of this Weierstrass approximation theorem. And with the help of some data, you can interpolate or extrapolate or differentiate, integrate, whatever you want, you can do. So there, this Weierstrass approximation theorem is very much applicable. The next application of this Weierstrass approximation theorem is in the construction of a function which is continuous everywhere and differentiable nowhere. So you might have seen an example of function which is continuous at a point. Example of a function. Example of a function continuous at a point, but not differentiable at that point. So I think this is not very difficult. You must have seen, in fact, several examples. Can anybody just reply quickly?
Mod x, sir.
Very good. So this, for example, this mod x is a function. Yes, this mod x is a function. So at x equal to 0, it is continuous, and but not differentiable at 2 points, but not differentiable at 3 points. So you can construct this kind of function with the help of this function. Similarly, you can also construct example of functions which are differentiable, say k times, but not differentiable k plus 1 times. So a function which is differentiable k times and its derivative is also continuous is known as ck functions. So ck functions are those functions which are differentiable k times, but not k times, and its derivative is also continuous, and its derivative is continuous. So here is an exercise for you. You must try to solve it. So construct an example of a function which is ck. So give an example. Of a function which is ck, k times differentiable, but not k plus 1 times. In particular, you may think of for k is equal to 1. For k is equal to 0, you are already there. ये example जो है k is equal to 0 के लिए तो सही है. K is equal to 0 is just collection of continuous functions. So c is equal to 0 means collection of continuous functions. So this mod x is continuous, but it is not c1. It is not differentiable. So in a similar way, you can construct function which is k times differentiable and continuous, but its derivative, but it is not differentiable k plus 1 times. So let us come to the application of Weierstrass approximation theorem, which says which help actually in the construction of a function which is continuous everywhere but differentiable nowhere. So maybe you can write in the form of maybe some proposition, or maybe question you can also think of. So there exists a real valued function, There exists a real valued function which is continuous on its whole domain. Maybe if you want to construct a function on the whole real line, so it's continuous on R, but nowhere differentiable. So first, this must be a wonder for you that really there exists a function which is continuous everywhere, because all these functions are just continuous but not differentiable at one point, not differentiable at 2 points. Maybe you can construct not differentiable at countable many points. But does really there exist a function which is continuous everywhere, but differentiable nowhere? So yes, so there really exists a function. And now I'm telling about the function. So for construction, let us consider a function f. So consider a function f which is periodic of period 2. So maybe here is your 0, here is 1, and here is 2. So if you construct the graph of the function on this interval 0 to 2, you can just repeat this graph on the whole real line to find the graph of the function on the whole real line. So suppose let f is a function. F is a real valued function. Defined on this R and periodic with period just 2. That is this f x plus 2 is equal to fx for all x in R. For all x. This is a function is said to be periodic with period say L, if fx plus L is equal to fx for every x belongs to R. And now, so you must define the function at least on the interval of length 2. अगर इस length 2 में अगर आप define करते हैं, so then you just repeat this function to get the whole graph. So now we define on this interval 0 to 2. So suppose this fx is equal to x in this first half interval when x belongs to 0, 1, and is equal to this 2 minus x when x belongs to 1, 2. Right? Is 2 minus x when x belongs to 1, 2. So can you plot the graph? So suppose this is your y-axis, this is your x-axis. Now 0 to 1, in 0 to 1 is a part of this straight line, y is equal to x. And at x is equal to 1, its value is 1. So from here at x equal to 1 also its value is 1. So therefore the function is continuous at 1. But from 1 to 2, the graph is this straight line y is equal to 2 minus x. That is x plus y is equal to 2. So you can join the line segment for x equal to 1 and x equal to 2. So at x equal to 2 it is 0. So at x equal to 2 it is 0 and x equal to 1 it is 1. So you just join these 2 points to get the line segment joining these 2 points. So this is the graph of the function on the interval 0 to 2. And you can just repeat this graph on another say 2 to 4, another interval 2 to 4, you get this repeated graph, and again this repeated graph here also. So on the whole real line, you get this repeated graph. Right? So this is a function fx which is continuous on the whole real line. Right? Is it okay to everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
So,
sir.
so clearly this f is continuous.
Yes,
Clearly this f is continuous on the whole real line R. Yeah. Now we consider a function. This is not our main function. So this is just the helping function, you can say. Now we construct a function f capital F from R to R defined as follows. So consider a function f or construct a function f as follows. So in fact, before the definition, let us consider this infinite series. And this infinite series is this 3 upon 4 to the n and small f 4 to the power nx. And n is equal to 0 to infinity. 0 to infinity. N varies from 0 to infinity. So we consider this infinite series, and we'll soon see that this infinite series actually is convergent. So this converges to some function, and let us call that function as fx. Right? So we'll soon see that this infinite series is convergent. In fact, converges uniformly and absolutely on the whole real line. So it's very simple application of Weierstrass M test. We just see each term of the series because this f is bounded. You see, this f is bounded. So small f function है, ये bounded function है. It always lies between 0 and 1. ये हमेशा 0 और 1 के बीच में lie कर रहा है. It always lies between 0 and 1. So therefore, because this fx is bounded, it always lies between 0 and 1. So each term, so if you consider nth term of this infinite series, this nth term, modulus of nth term is less than equal to this 3 to the power 3 upon 4 to the power n. So this is your mn. This is your mn of Weierstrass M test. And you know this series is geometric series which is convergent. So therefore, this infinite series is dominated by a geometric series which is convergent, and therefore this series by Weierstrass M test is convergent. And therefore it converges uniformly and absolutely to a function. And let us call that function as capital F. Is it okay?
Yes, sir.
Yeah. Now you see, because this, each term of the right hand side is continuous. Each term of this series, infinite series, is continuous because F is continuous. F is continuous. So each term is continuous. So therefore its uniform limit is also continuous on the whole real line. Right? Because each term is continuous, so its uniform limit is also continuous. So therefore this F is continuous. So now this is our main function. So just to inform you that this is our main function, and you can see that because of the uniform convergence of this infinite series, this limit function is actually continuous on the whole real line. And now we shall prove that, we'll have to prove that actually this function is nowhere differentiable. This function is nowhere differentiable. So because so since, so should I write each and everything or ये आप लोगों को क्लियर आप लोग लिख लेंगे ना बीच में एक दो स्टेप जैसे मैं एक जो बोल रहा हूँ because this f is bounded, so therefore nth term is dominated by this 3 upon 4 to the power n, and because this nth term is less than equal to this term by Weierstrass M test, and the series, if you consider this series 3 upon 4 to the power n is a geometric progression, is a convergent geometric progression, and therefore by Weierstrass M test, this infinite series is uniformly absolutely convergent to some function, and let us define that function is f. तो ये आप लोग लिख लेंगे ना ये बात?
सर मेरे एंड पे नेटवर्क इशू है, तो आप लिख देंगे तो क्लियर हो जाएगा, आवाज सही से नहीं आ रही है।
ओह सॉरी, ओके। सो
सर कुछ लोग ज्वाइन होना चाहते हैं।
बाउंडेड, f is bounded by this number 1, bounded by 1, that is this fx is less than equal to 1 for all x belongs to R. This nth term of the series, this 3 upon 4 to the power n, f4 to the power nx, this will be less than equal to 3 upon 4 to the power n. Now, since this 3 upon 4 to the power n, this series is a convergent geometric progression by Weierstrass M test. The series, the sigma n is equal to 0 to infinity 3 upon 4 to the power n f 4 to the power nx uniformly and absolutely converges to a function say fx. Now, since each term of the series is continuous, each term of the series is continuous, the uniform limit fx will also be continuous on the whole domain. Yeah. So now you have to show that this function f is actually differentiable nowhere. So now my claim is to show that this f is differentiable nowhere. f is differentiable nowhere. कोई ऐसा पॉइंट नहीं है जहां पे f डिफरेंशिएबल होगा. हालांकि ऐसा लग रहा है कि जो स्मॉल f फंक्शन है वो तो एक लाइन सेगमेंट है. इनफैक्ट 0 to 1 और 1 to 2 में लाइन सेगमेंट आपको मिल रहा है, लेकिन अगर आप इसका ग्राफ अगर आप ध्यान से देखें इस पूरे फंक्शन कैपिटल f का, तो आप ऐसा महसूस करेंगे कि ये किसी भी पॉइंट पे डिफरेंशिएबल नहीं है. बट प्रिसाइसली हम उसको प्रूफ करेंगे, हम दिखाएंगे कि हाँ ये डिफरेंशिएबल नहीं है. लेकिन जरा इसका ग्राफ अगर आप लोग समझें कि ग्राफ क्या है. सो योर फर्स्ट फंक्शन वाज दिस स्मॉल fx, ये जो सीरीज आपकी है कैपिटल fx, this capital fx, this was actually the first term. So this was 3 upon 4 to the power n and f4 to the power nx. So its first term, this n varies from 0 to infinity. So for n is equal to 0, this is simply fx. For n is equal to 1, it is 3 upon 4 and f4x, and plus 3 upon 4 square and f4 square x, and plus dot and so on. तो fx का ग्राफ तो आपने देखा. So the graph of fx is just it was suppose this is 0, this is 2, this was 4. So this kind of graph is your graph of fx, right? What about graph of f4x? So let us add few terms of this series, and then you have at least some idea that how it will look like. So what is the graph of f4x? तो ग्राफ ऑफ f4x, अगर मान लीजिए कि आप 0 to 4 इंटरवल में अगर आप इसको प्लॉट करना चाहें, तो लेट अस कंसीडर द नेक्स्ट पेज. या सो मे बी यू सी हियर. सो yeah, so this is your 0, here is your say 2, here is your 4, in between here is your 1. So this was graph in between 0 to 2. Fx is equal to x, and 2 minus x when x lies between 0 and 1, and when x lies between 1 and 2. Now, what will be the graph of f4x? So in fact, what is its period? So you see the period of the function f was 2. So here the period of this function f4x will be कितना हो जाएगा? You just divide by 4. Is it clear to everybody? So therefore, if you obtain the graph of this function f4x on just 1/4 of the domain of this function f, that is on say 0 to 1/4 of this 0 to 2, that is 0 to half, 0 to half, 0 to half, then you just repeat this graph on the whole real line and you can get the graph of f4x. So for example, when x lies between 0 and say 1/4, 0 and 1/4. So you see here 0 and 1/4. So in between these two, its value is simply x. And when your x lies between 1/4 to 1/2, right? 0 to 1/4, it is x, and 1/4 to 1/2, it is 2 minus. I think there is a mistake. So when you will reach x is equal to half, I think it is 4x, sorry. So it is 4x. And when 1/4 to 1/2, it is 2 minus 4x. Yeah. So when you reach 1/2, it is 0, and at 1/4, it is 1. So 1/4, it is 1. So it's look like this. 1/4, it is 1, and again it is look like this. So in between 0 to 1/4, the graph of the function is this 4x, and from 1/4 to 1/2, your graph is 2 minus 4x. Yeah, and you repeat this. So from 1/2 to 1, it also look like this same figure. Same figure. Yeah. Is it okay? Now what you have to do, you have to multiply this thing by 3/4. So it means you have to just, yeah.
सर ग्राफ फिर से एक बार समझा दीजिए, ये कैरी कैसे कर रहा है 0 to 1/4?
नहीं, 0 to 1/4 में ये ग्राफ क्या है? You just use the function fx is equal to x. So f4x is equal to 4x. ठीक है? So you just put x is equal to 4y. अगर x is equal to 4y इसमें रखो तो f4y is equal to 4y. Here is also x equal to 4y. And when x lies between 0 to 1, 4y lies between 0 to 1. So y lies between 0 to 1/4. तो केवल आप पैरामीटर चेंज कर दीजिए, तो जब x 0 और 1/4 के बीच में होगा, अगर आप मान लो इस एक्सप्रेशन में x is equal to 4y आप पुट कर लीजिए, put x is equal to 4y. So what happened? So this f4y is equal to 4y, and when this 4y lies between 0 and 1, that is y lies between 0 and 1/4, and here 2 minus 4y when 4y lies between 1 and 2, so therefore y lies between 1 upon 4 to 1 upon 2, right? तो 0 और 1 upon 2 के बीच में आपको ये ग्राफ मिल रहा है. 0 और 1 upon 4 के बीच में ग्राफ इज गिवन बाय दिस 4y. f4y is equal to 4y, and this 2 minus 4x is this line. Why? At x is equal to 1 upon 4. अगर x equal to 1 upon 4 इसमें पुट करिएगा तो आपको 4 से 4 कैंसिल 1 आ जाएगा. एग्जैक्टली 1 वैल्यू आएगी, 1 हो जाएगा. और जब 1 upon 2 आप रखेंगे, 1 upon 2, तो 4 upon 2, 2 minus 2 0, तो इस पॉइंट पे 0 हो जाएगा. इसका मतलब ये शार्पली बहुत ही तेज ऊपर गया और फिर नीचे आ गया. और चूंकि पीरियडिक है 1 upon 2 पीरियड का, तो इसका मतलब ये रिपीटिशन ऐसा ही शुरू हो जाएगा. तो पूरे रियल लाइन पे इसको आप प्लॉट कर लीजिए. अब इसमें 3 upon 4 से जो सेकेंड टर्म है सीरीज का, वो क्या है? दिस fx इज इक्वल टू स्मॉल fx प्लस 3 upon 4 एंड f4x and plus 3 upon 4 square f4 square x and plus डॉट डॉट. ये प्रोसेस इनफाइनाइट तक ले जाना है. तो इसमें 3 upon 4 से आपको अभी मल्टीप्लाई करना है. तो 3 upon 4 से मल्टीप्लाई करने का मतलब ये जो इसका हाइट है उसको 3 upon 4 से आपको सॉर्ट कर देना है. तो यू जस्ट स्केल बाय 3 upon 4. तो 3 upon 4 से अब स्केल करेंगे तो अब इसकी हाइट जो है वो इसके 3 upon 4 ये साइड हो जाएगा. जस्ट स्केल इट बाय 3 upon 4. So maybe you can use different color. Yeah. So this 3 upon 4. So this is your new function. Actually the second term of the series. You just scale it by 3 upon 4. Right? Okay. Now suppose you add these two functions. मान लीजिए कि इन दोनों फंक्शन को अगर आप ऐड करें तो क्या होगा? What will happen? So suppose in the interval 0 to 1 you want to the graph of the sum of these two functions. तो क्या होगा? 0 to 1 में ये ग्राफ आपका है फर्स्ट फंक्शन का है y is equal to x लाइन, और ये जो सेकेंड फंक्शन है इसका ग्राफ है which is given by these two in fact 4 line segments. अब इनको जब आप ऐड करेंगे तो जो नेक्स्ट फंक्शन मिलेगा fx plus 3 upon 4 f4x, that will look like this figure. It look like this figure. So here was your triangular shape, and now you just add these two. Maybe look like something this, and this, and this. You have to just remove this triangle figure. Is it okay?
Yes, sir.
यस
तो ये तो केवल अभी 2 टर्म का सम हुआ. अगर फिर तीसरे का सम जब आप करेंगे तो फिर इसके हर साइड के ऊपर आपको फिर इस तरह के शेप्स आपको मिलने शुरू हो जाएंगे. और फिर आप इसी तरह नेक्स्ट टर्म को ऐड करेंगे, हर साइड पे जितने आपको साइड मिलेंगे हर साइड पे इस तरह से आपको फिगर मिलने शुरू हो जाएंगे. उनका हाइट निश्चित रूप से कम रहेगा, तो छोटे छोटे हाइट के ट्रायंगल्स आपको फिर उस साइड पे फिर छोटे साइड के आपको इस तरह के शेप मिलने शुरू हो जाएंगे. एंड फाइनली यू विल गेट यू से द एक्चुअल ग्राफ ऑफ दिस फंक्शन fx, एंड you can see that इतने छोटे छोटे ट्रायंगल्स आपको मिलने शुरू हो जाएंगे. You finally at least you can feel that it is not differentiable. जितने कॉर्नर्स हैं उन हर कॉर्नर पे फंक्शन डिफरेंशिएबल नहीं है, और ये कॉर्नर हर इंटरवल पे बढ़ते जा रहे हैं. तो फाइनली ऐसा आपको महसूस होना चाहिए कि किसी भी पॉइंट पे आप जाएंगे तो जरूर ऐसा एक कॉर्नर दिख जाएगा और वहां फंक्शन आपका डिफरेंशिएबल नहीं होगा. बट ये केवल एक फीलिंग हो सकती है. You need a precise proof, and now I'm going to prove this fact that this capital F is actually not differentiable at any point on this real line. Is it okay to everybody?
Yes, sir.
Yeah.
यस
Okay. So before proving this fact, the non-differentiability of the function, we actually need a lemma. So first I am proving this lemma. क्योंकि इसमें जो हम डिफरेंशियबिलिटी की बात करेंगे तो उसमें एक स्पेशल काइंड ऑफ डिफरेंशियबिलिटी हम यूज करेंगे, उसको प्रूव करने के बाद हम तब इस रिजल्ट को प्रूव करेंगे. सो लेट अस कंसीडर दिस लेमा. So suppose f is a function defined from interval ab to r, and suppose this f is differentiable, and let this f is differentiable on this interval ab. इस ओपन इंटरवल ab में ये मान लीजिए डिफरेंशिएबल है, and especially at some point say maybe you fixed a point in between AB, maybe you take a point say C or say x0. So let f is differentiable at कर लीजिए at a point this x0 which lies between this open interval AB. Now if you consider this kind of numbers, so this is your A, this is your B, and here is your x0. Now consider numbers, this alpha 1, alpha 2, alpha 3, dot dot alpha n, and similarly this right to x0, this beta 1, beta 2, beta 3, dot dot beta n, so that this alpha n is an increasing sequence and beta n is a decreasing sequence. So if this A is less than say alpha n, alpha 1, alpha 2, alpha 3, alpha n, and less than this is x0, this is less than beta n, and beta n is strictly less than b. So this is true for each n, for n is equal to 1, 2, 3, and dot dot. And you need one more condition, that this beta n, beta 1, 2, 3 decreasing sequence है जो x0 पे converge कर रहा है. This beta n converges to x0, and alpha n, which is an increasing sequence, this also converges to x0. So this alpha n converges to x0 and beta n converges to x0. Then show that the derivative of the function at the point x0 is actually equal to this limit f beta n minus f alpha n upon beta n minus alpha n and n tending to infinity. Right? Is it okay?
Yes, sir.
Yes, sir.
So you can think of, suppose you consider only this decreasing sequence, then you actually know that this f beta n minus fx0 upon beta n minus x0. अगर आप इस बीटा n को x0 plus h लिखें तो बेसिकली ये डेरिवेटिव का डेफिनेशन है. तो इफ दिस लिमिट एग्जिस्ट, so limit n tending to infinity, this is nothing but you can say right hand derivative of the function f at x0. So this is in fact f dash x0. So because this function is differentiable, it is given that function is differentiable, this limit exists and it is equal to f dash x0. And similarly, you also know that this fx0 minus this f alpha n divided by x0 minus alpha n and limit n tending to infinity. So this is again equal to left hand derivative at the point x0. If you put this alpha n is equal to x0 minus h, this is nothing but the left hand derivative, and because function is differentiable, left derivative equal to right derivative, so this is again equal to f dash x0. So these two equations you know already, but you have to show that you don't need actually x0 in this limit, if you only know two sequences, one is increasing, another is decreasing, and you only know the ratio of this term, this f beta n, f alpha n, beta n minus alpha n, and alpha n and beta n are two sequences of a special kind, that one is increasing, another is decreasing, and both converges to x0, then this is actually the limit of this derivative is actually the limit of this quotient. Okay, so now the proof is not very difficult. It's just a simple manipulation of these limits. So up to this level, everything is okay to you? किसी को कोई दिक्कत तो नहीं है ना अभी?
No, sir. No, sir.
Okay. Now I am considering this a quotient lambda, which is equal to this beta n minus x0 divided by this beta n minus alpha n. So beta n है, beta n में x0 को डिवाइड करिए और फिर बीटा n में अल्फा n को डिवाइड करिए. तो डेफिनेटली you see, because beta n is right to x0, it is positive, and beta n is also right to alpha n, so this is also positive. So numerator and denominator both are positive numbers. And also this beta n minus x0 is less than beta n minus alpha n. It's clear from the assumption. So therefore this lambda lies between 0 and 1. Is it clear to everybody? In fact, you may call this lambda n. You may call this lambda n. So clearly this lambda n always lies between 0 and 1. Now what is 1 minus lambda n? What is 1 minus lambda n? If you subtract, so you will get beta n 1 minus this quotient. So you get beta n minus alpha n minus this quantity. So beta n cancel out, and you will get this x0 minus alpha n upon beta n minus alpha n. So here again, this x0 minus alpha n is positive number, and beta n minus alpha n is positive number. And again, x0 minus alpha n is less than beta n minus alpha n. This 1 minus lambda n is also, it lies between 0 and 1. Okay. Now we consider this quotient. So you can write this f beta n minus f alpha n and divided by this beta n minus alpha n. And you have to show that this will actually, the limit of this as n tending to infinity is actually f dash x0. So maybe you can estimate the difference between these two, f dash x0. So let us find the estimate of this difference, and we'll show that it's actually less than epsilon whenever n is bigger than some n, and therefore this limit of this sequence will converge to f dash x0. ये हमको देखना है कि क्या इसका एस्टिमेट जो है वो किसी एक पॉजिटिव नंबर, वो हमारे ऊपर डिपेंड करेगा एप्सिलॉन, तो वो आर्बिट्ररी पॉजिटिव एप्सिलॉन वेदर दिस इज लेस देन और नॉट. So this can be written as, हम इसमें थोड़ा सा मैनिपुलेशन हम करने जा रहे हैं, और वो मैनिपुलेशन ये है कि ये बीटा एन माइनस अल्फा एन, ये डिनोमिनेटर में वही चीज है जो यहाँ पे अल्फा एन में है. तो पहला चीज तो हम करेंगे इसमें एफ बीटा एन और एफ अल्फा एन है, तो हम इसमें एफ एक्स जीरो लाना चाह रहे हैं. बेसिकली हम इन एक्सप्रेशंस का यूज करना चाहते हैं. तो एफ बीटा एन माइनस एफ एक्स जीरो हम लिखना चाहते हैं, और उसी तरीके से एफ एक्स जीरो माइनस एफ अल्फा एन हम लिखना चाहते हैं. लेट अस ऐड एंड सब्ट्रैक्ट एफ एक्स जीरो. तो एफ बीटा एन माइनस एफ एक्स जीरो एंड प्लस एफ एक्स जीरो माइनस एफ अल्फा एन and divided by this beta n minus alpha n minus f dash x0, and this is equal to, अब f beta n minus f x0, तो इसका डिनोमिनेटर हमको चाहिए बीटा एन माइनस एक्स जीरो. तो लिख लीजिए बीटा एन माइनस एक्स जीरो, बीटा एन माइनस एक्स जीरो से मल्टीप्लाई डिवाइड करिए. So you will get this beta n minus x0 divided by beta n minus alpha n. So beta n minus x0 and divided by beta n minus alpha n is nothing but lambda n. So you can write this lambda n into this f beta n minus fx0 divided by this beta n minus x0 and minus f dash x0. We'll just write this minus f dash x0 and plus this remaining term fx0 minus f alpha n. So fx0 minus f alpha n, you need in denominator this x0 minus alpha n. So again multiply divide by x0 minus alpha n. So x0 minus alpha n and divided by beta n minus alpha n. So x0 minus alpha n, here you see x0 minus alpha n divided by beta n minus alpha n is nothing but 1 minus lambda n. So plus 1 minus lambda n into this fx0 minus f alpha n divided by this x0 minus alpha n and minus f dash x0. And you see this f dash x0 1 minus lambda n and f dash x0 lambda n, this lambda n cancel out and you will remain with this f dash x0. So therefore it will not change anything. So जी okay to everybody up to this level? हमने केवल fx0 को ऐड किया न्यूमिनेटर में और सब्ट्रैक्ट किया और उसके बाद थोड़ा सा मैनिपुलेशन हमने अपने नीड के अकॉर्डिंग किया सो दैट this limit becomes exactly f dash x0, this limit exactly becomes f dash x0 और हमारा काम आसान हो जाए. ठीक है? किसी को कोई दिक्कत तो नहीं है ना इस लेवल तक? तो अब आप देखें कि ये जो लिमिट है दिस द लिमिट ऑफ दिस कोशेंट इज एक्चुअली f dash x0. इसका मतलब आप जितना छोटा एप्सिलॉन चाहें उतना छोटा एप्सिलॉन आप ले सकते हैं such that the estimate of the difference between this and left hand side is less than as small as you please. Maybe you want epsilon by 2, you can do. So you get a natural number n such that whenever n greater than that natural number, the estimate is less than epsilon by 2. And similarly, here also, if you want to estimate this difference less than epsilon by 2, you must find a natural number such that whenever n greater than that number, its estimate is less than epsilon by 2. Now, if your natural number, say n1 is in left first term and n2 second term, you can now choose a natural number which is bigger than those numbers, maybe maximum of n1 and n2. So this is less than epsilon by 2, this is less than epsilon by 2. And now you take epsilon by 2 outside so that this lambda and cancel out and you will get exactly epsilon by 2 plus epsilon. Oh, I think epsilon is enough. So you just take epsilon. So therefore this is less than epsilon. So the modulus of this estimate is less than epsilon whenever your n is bigger than the maximum of n1 and n2, and therefore the limit of this first term is nothing but f dash x0. So therefore the limit of this term, this left hand side, in fact the first term is equal to f dash x0. Are you getting my point? किसी को कोई कंफ्यूजन तो नहीं है अभी? आप लोग मेरी बात सुन रहे हो कि नहीं?
नो सर, कोई दिक्कत नहीं.
हाँ, ठीक है. तो finally this lemma is proved that for differentiability at a point we only need this quotient f beta n minus f alpha n divided by beta n minus alpha n as n tends to infinity. अगर आप ये suitably chosen, अगर ये sequence अगर आप लेते हैं तो ये sequences पे फंक्शन की वैल्यू निकालिए, उनका डिफरेंस लीजिए और उससे क्वोशिएंट करिए, लिमिट लीजिए, दैट इज द डेरिवेटिव. वी डोंट नीड एक्चुअली x0 एनीवेयर इन दिस क्वोशिएंट. ओके, so now we'll come to the proof of the second part of our theorem, that this function f is actually, so your function f, I just write it again, this fx which is equal to the sigma n is equal to 0 to infinity and 3 upon 4 to the power n and f 4 to the power nx. This was our function. And you have to show that this function is differentiable nowhere on R. So let us take x0 is some real number. We say x0 is some real number. So you have to show that this function is not differentiable at x0. x0 is some point. Suppose some adjustment is here. Please be mentally prepared that we have to adjust something. So suppose m is a fixed integer. Let m be a fixed integer. m be a fixed integer. कोई integer एक ले लीजिए. And x0 is a number in the and this x0 is a real number on x0 is an element of R. Okay. So you see here, when you multiply this x0 by 4 to the power m is fixed number, you will get some number. कोई number आपको मिलेगा जिसको हम कह रहे हैं 4 to the power m x0. x0 is any real number. अब इस नंबर के जस्ट आगे और जस्ट पहले ये जो दो इंटीजर्स मिलेंगे, उन इंटीजर्स को हम कह रहे हैं से k and k plus 1. Because x0 is fixed, m is a fixed integer, so this 4 to the power m x0 is some real number. And now let us call the just succeeding and preceding integers as k plus 1. So let this k be integer, k be an integer such that this 4 to the power m x0 is less than equal to k plus 1 and greater than equal to k. Right? Now, you consider, so you take this, if you divide this real number 4 to the power m upon x0 by 4 to the power m, you will get this number. इसमें 4 to the power m क्योंकि इसके जस्ट पहले और जस्ट बाद का नंबर है, तो इसी तरह से k में अगर 4 to the power m से डिवाइड करें तो इसके पहले एक नंबर मिलेगा. So you will get a number here, what you may call 4 to the power minus mx0, and similarly, 4 to the power minus m into k, not x0. 4 to the power minus m into k is a number just before x0, and this 4 to the power minus m and k plus 1 is a number just after x0. And now you may call this number as alpha m and this number as beta m. You can prove that this alpha and beta, m and beta m, these two numbers, these two in fact sequences satisfy all the conditions we just actually needed in the last lemma. The last lemma में हमने जो अल्फा m और बीटा m लिया है कि अल्फा m जैसे जैसे m की वैल्यू आप बढ़ाते जाएंगे ये इंक्रीजिंग सीक्वेंस होगा, और यहाँ जब बीटा में m की वैल्यू बढ़ाते जाएंगे तो एक डिक्रीजिंग सीक्वेंस होगा, एंड फाइनली they will converge to x0 as m tending to infinite. Is it okay to everybody?
Yes, sir.
Okay. So this is your alpha m and beta m. Alpha m and beta m. अब एक बार फिर अगर इस अल्फा m और बीटा m में अगर 4 to the power n से आप मल्टीप्लाई करिए 4 to the power n, so you will get, so this 4 to the power n alpha m is nothing but 4 to the power n minus m into k. 4 to the power n minus m into k. Right? When n is equal to m, जब n की वैल्यू एग्जैक्टली m हो जाएगा तो इसकी वैल्यू केवल k रहेगा, एग्जैक्टली दिस नंबर k. And similarly, this 4 to the power n beta m is equal to 4 to the power n minus m into k plus 1. right? Now your m was fixed integer. N is variable. N एक variable number है, variable integer है. So we consider three cases, in fact, when n greater than m. मान लीजिए n आपका m से बड़ा है. Suppose this n is bigger than m. Then your 4 to the power n alpha m and minus 4 to the power n beta m, when you will calculate, what will you get? अगर इनको आप subtract कर दें 4n alpha m and 4n beta m, when you will subtract, what will you get? In fact, this, because beta is bigger, so maybe you subtract this from this. So maybe you'll write this as plus sign and this as minus sign. It's not a problem. So 4 to the power n beta m minus 4 to the power n alpha n, when you will subtract, so you will get exactly 4 to the power n minus n. Is it okay?
Yes, sir.
Yes, sir. Yes, sir.
a plus 1 में से k माइनस हो जाएगा तो केवल 1 बचेगा, तो 4 to the power n minus n. और जब n is equal to m होगा, when n is equal to m, so this is exactly 1. 4 to the power n is equal to m रखिए, 4 to the power 0 is equal to 1. So, and when n bigger than m, n and m both are integers, so you will get 4 to the power some integer, maybe 1, 2, 3, 4, 5, 6, something like that. And n is bigger than m, so this is an even integer. So this must be an even integer. Right hand side must be an even integer. Must be an even integer. Right? And when n is equal to m, if n is equal to m, then this 4 to the power n beta m minus 4 to the power n alpha m, this difference is just 1. Because 4 to the power 0 is 1. Now what happens if n is less than m? What happens if n is less than m? When n is less than m, is there any integer between 4 to the power n beta m and 4 to the power n alpha m? You see, ये k plus 1 दो consecutive integers हैं. दो consecutive integers हैं जब x0 में 4 to the power m को मल्टीप्लाई कर रहे हैं. ठीक है? And this k divided by 4 to the power m is alpha m. And k plus 1 divided by 4 to the power minus m is beta m. तो जब इसमें आप 4 के पावर से मल्टीप्लाई करेंगे अल्फा m बीटा m में, जब आप एग्जैक्टली n इज इक्वल टू m मल्टीप्लाई कर रहे हैं तो आपको अल्फा m और बीटा m, ये आपका अल्फा m इंटू 4 टू द पावर m है और ये बीटा m इंटू 4 टू द पावर m है. तो अगर इससे बड़े नंबर्स के लिए मल्टीप्लाई करेंगे तब तो ठीक है, आपको बीच में इंटीजर्स मिल सकते हैं. बट व्हेन दिस n इज लेस देन m, ये अल्फा m इंटू 4 टू द पावर m एंड बीटा m इंटू 4 टू द पावर n, इन दोनों के बीच में कोई इंटीजर नहीं मिलने वाला है, क्योंकि जब m से मल्टीप्लाई करेंगे तब तो डिफरेंस 1 का आ रहा है. आर यू एग्री विद मी?
यस सर.
यस सर. देखिए, ये अल्फा m और बीटा m ये दो नंबर्स हैं. इसमें जब आप 4 टू द पावर m से मल्टीप्लाई कर रहे हैं, 4 टू द पावर m से मल्टीप्लाई कर रहे हैं, तो ये वैल्यू हो जा रही है k और ये वैल्यू हो जा रहा है k प्लस 1. अगर ये m जो है, अगर m से कोई छोटा नंबर आप m minus 1, m minus 2, m minus 3, तो इनफैक्ट इफ यू टेक एनी n which is less than m, एनी n विच इज लेस देन m, इन दोनों का डिफरेंस जो होगा वो एक, इन दोनों के बीच में इनफैक्ट कोई इंटीजर लाई करने वाला नहीं है. सो नो इंटीजर लाई बिटवीन 4 to the power n beta m and 4 to the power n alpha m. Okay, so now I am calculating this difference, this f 4 to the power n beta n and minus f 4 to the power n alpha m. So this difference is going to be, you just see, इनका डिफरेंस क्या होगा, 4 to the power n beta n and 4 to the power n alpha n. इनका डिफरेंस when n bigger than m and when n less than m, less than or equal to m. What is this? Are you agree that this is equal to 0 and this is equal to 4 to the power n minus m?
Yes, sir.
When n bigger than m, when n bigger than m, this is 0. Why? Because इन दोनों के बीच में कोई इंटीजर्स नहीं है. 4 to the power n beta n और 4 to the power n alpha n के बीच में कोई इंटीजर्स नहीं है. और f की वैल्यू, ओरिजिनल वैल्यू क्या है? जब दो वैल्यूज आप ले रहे हैं 0 और 1 के बीच में उसकी वैल्यू x है और 1 और 2 के बीच में उसकी वैल्यू 2 माइनस x है. तो अगर मान लीजिए कि दो वैल्यू x1 x2 ले रहे हैं, अगर वो 0 1 के बीच में है, इसी तरह से और भी किन्हीं दो इंटीजर के बीच में नंबर्स लेंगे, तो x1 x2 और दोनों पे उसकी वैल्यू देखिए, अगर आप ले रहे हैं in fact your fx fx was defined as x when x lies between 0 and 1 and when lies between 1 and 2 its value is 2 minus x, right? So when n bigger than m, when n bigger than m, you see its difference is just the, अगर 0 और 1 के बीच में है तो इनका डिफरेंस आपका होगा x1 minus x2, और अगर 1 और 2 के बीच में होगा तब भी डिफरेंस 2 minus x1 minus m when n less than equal to m. Is it okay?
ग्रेटर देन m पे है ना सर?
n ग्रेटर देन m पे है, n ग्रेटर देन m पे है.
सर n ग्रेटर देन और इक्वल टू m पे होना चाहिए.
यस सर, n ग्रेटर देन इक्वल टू m पे होना चाहिए.
n ग्रेटर देन m पे है तो इसकी वैल्यू है 4 to the power n minus m. Something is missing. 4 to the power n beta m and 4 to the power n alpha n. m is a fixed integer, m एक आपका fixed integer है, और m से बड़ा जब आप n ले रहे हो तो this is n minus m, that is okay. So that is an even integer. To the power n beta n. आप लोगों का क्लास है ना? हाँ हाँ हाँ.
यस सर.
Yes, sir. Class.
जस्ट ए मिनट
सर कंडीशन उल्टी हो गई है सर। जब सर कंडीशन उल्टी हो गई कि जब हम लोगों का n m से बड़ा है तो हम लोग 0 ले रहे हैं, जबकि हम लोग को लेना चाहिए 4n माइनस m।
ये सर आपके ऊपर शो तो किया है।
नहीं, वो सही है। वो एक्चुअली ऐसा है ना कि इन दोनों का जो डिफरेंस है, ये डिफरेंस एक इवन इंटीजर है। ध्यान दीजिए, ये जो दोनों नंबर्स है ना, इनका डिफरेंस एक इवन इंटीजर जब होगा, तो आप ध्यान दीजिए कि जब इवन इंटीजर का मतलब जो अगर 2 पॉइंट्स अगर आप ले लो और इनका डिफरेंस अगर इवन इंटीजर है, राइट, इवन इंटीजर, तो बिकॉज योर फंक्शन इज पीरियडिक ऑफ पीरियड 2, तो जो यहाँ पे फंक्शन की वैल्यू होगी वही यहाँ पे फंक्शन की वैल्यू हो जाएगी, राइट। तो जब इन दोनों पॉइंट के बीच का, जब n m से बड़ा होगा, व्हेन n इज बिगर देन m, तो इन दोनों के बीच का डिफरेंस एक इवन इंटीजर है। तो इवन इंटीजर जब है तो यहाँ पे जो फंक्शनल वैल्यू का डिफरेंस होगा दैट विल बी 0, राइट। ध्यान दीजिए, जो पॉइंट्स हैं 4 टू द पावर n बीटा m और 4 टू द पावर n अल्फा m, ये दोनों पॉइंट के बीच का डिफरेंस क्या है? एक इवन इंटीजर है। तो जब इवन इंटीजर है और जो फंक्शन f है, दैट फंक्शन इज पीरियोडिक ऑफ पीरियड 2। So therefore, when n bigger than m, then the functional difference, the difference of the functional values at these 2 points must be 0, right? And now I will explain later on, maybe tomorrow, why this, when n less than equal to m, why it is 4 to the power n minus m, and then we'll calculate the sum and we will see that actually the quotient जो हमने अभी लेमा में प्रूफ किया है, that quotient will not converge to any finite limit. तो इसको next time हम लोग प्रूफ करेंगे।
सर स्लाइड को शेयर कर दीजिए।
हाँ, इसको मैं शेयर